So here, as we said in this example, so we have y prime plus 3y equal x squared plus 1. This is of that form. So first of all, I find the general solution. I equate it to 0, so it's y1 equals c e power minus 3x. And then I gave you, the second one must be ax squared plus bx plus c particular solution. Degree 2, I take degree 2. So I derive it here. As you can see, y prime here is 2ax plus b. I replace y prime, and the y2 here by here I equate it to x squared plus 1. I have the general solution plus the particular solution here that we found. If I continue, suppose here, similarly, this is of which form? It's of the form y prime plus ay equal f of x. So first of all, I solve for y prime plus y equal to 0. Y prime plus y equal to 0, so directly it's ce minus x. This is C belong to R or arbitrary solution, constant. So now I want to find the general solution. If you have sine, I'm going to give you y2 equal a sine x plus b cos sine x. Work on it to find the particular solution. So I want y prime plus y, so I derive this one. You're going to get a cosine x minus b sine x. I replace it here. So this is a cosine x plus y which is a sine x plus b cosine x equals sine x. I put cosine x in factor and sine x. I equate to sine x. I don't have here cosine, so a plus b is 0 and a minus b equal to 1. So I have a and b. So what will be the particular solution that was given? So y2 will be half sine x minus half cosine x. I add it to what? To the general solution. Only the particular solution in this kind of problems will be given. Another example, here it's equal ex. So first of all, the general solution, I equate it to 0. It will be ce minus 2x. Let y2 equal kex. I gave you y2 kex. If you derive it, it's kex. Replace it here, plus 2 kex equal ex. You can get rid of all the ex. So k will be 1 over 3. So what will be the particular solution? 1 over 3 ex. You add it to ce minus 2x, which is the general solution of this differential equation. So you need to memorize the whole table here. It's very important to memorize the table. If you have separable variable, when you put f of x alone and f of y alone, you integrate both sides. If you have it y prime plus axy equal to 0, you memorize this formula and you continue from here directly. And particular solution here, y will be 0. If you have y prime plus ay equal to 0, we talked about it a lot in the previous video, y equals ce minus ax, and the particular solution y equal to 0. And you have equal to b. This is the particular solution, this is the general, and this is the set of solution. So ce minus x, ex plus b over a. Here y1 equals ce minus ax, the general, and y prime for y prime plus ay is 0, and b over a, the particular solution. And if you have y prime plus ay equal to f of x, it will be ce minus ax plus y2. y2, to find here y2, will be given, like here in this example. So they give you y2 to find it, so that you can write it. So you need to memorize all of these. This is to memorize by heart. Now, differentiable equation of the second order, you have y double prime equal h of x. So here, it's very easy. You integrate twice. Let us take this one. Suppose y double prime equals sine 3x. If you integrate the first one, minus 1 over 3 cosine 3x plus c1. To find one y, I integrate again. So it will be minus 1 over sine 3x plus c1x plus c2, where c1 and c2 are constant or belong to the real number. Differentiable of second order with real coefficient and without a second number. If you have it ay double prime plus by prime plus cy equal to 0. So I'm going to take, let's suppose y equal e3x. If you do it, y prime are e3x, y double prime. If you replace it here, you can check it by yourself. So exponential cannot be 0. So ar squared plus br plus c is 0. It's called the characteristic equation of this differential equation. So depend on the roots. If you have two distinct roots, directly you have y equals c1 er1x plus c2 er2 of x. If you have, let us take this example. If you have y double prime plus y prime minus 2y is 0, it's of that form. Directly, without doing all of that process, say this is r squared plus r minus 2. Here I don't have r, please. Minus 2 only equal to 0. So if you put in the calculator you have two roots, 1 and minus 2, so y equals c1 ex plus c2 e minus 2x is the general solution. And if it's double root, this will be the result. Y equals c1 plus c2x e power rx. Let us take this one. If you have it of that form, which is ay double prime plus by prime plus cy equal to 0, so it can be written as we did here, but no need to repeat it. R square minus 4r plus 4 is 0. So here I have a double root, which is 2. So y will be c1 plus c2x e power 2x. Okay, we said it's in this example e power rx, so e2x is the general solution of this one. Now if it is complex, so you have this form, e alpha x, where alpha is the real, a sine beta x plus b cosine beta x, where beta is the imaginary part. Suppose you have this one, so you write r squared plus 2r plus 5 is 0. I have two complex here. So a alpha is minus 1, so I put e minus x into a sine beta is 2x plus b cosine 2x in this general solution. Now, if you have the second order of the form y double prime plus w square y equal to 0, and here it must be a positive, where w is a real number. It must be positive. You cannot have it negative. If you have it negative, it will be different. You go and do this one. It will be a double prime, you do plus by prime. Okay, now I'm talking sorry, you do a double prime plus cy equal to 0, you do this one. So here if w prime, this is always going to be complex. Why? Because r square plus w square is 0. It's the same as the one above. It's the same, and you can conclude it, but here you have more choices. So you have two complex roots. So as we said, this can be written as a sine wx plus b cosine wx, and more, you can write it as a sine a cosine, or a cosine wx plus b, or a sine wx plus b. Sometimes if you have multiple choice question, you're going to use depends on the choice, you may use this one or these. So if you have w prime plus 4y is 0, so w square is 4, so w is 2. So you write it as a sine 2x plus b sine 2x, or you write it as a cosine 2x plus b, which is the same as a sine 2x plus b. If you have it y double prime plus w square y equal to k, before, as you can see, it was equal to 0. If you have it the same but equal to k, so here the solution will be, you add to it k over w square, k over w square, k over w square. So these the types of differentiable equation of order 2 only, sorry, of order 2. You need to memorize it. If you have it y double prime equal hx, this is separable variable, you integrate twice. If you have it that form, you do second degree, ar squared plus br plus c. If you have two real distinct roots, you write it this form. If you have double root, you write it this form. If you have complex root, you write it this form. If you have it that form, it's either this one or that one or that one. You need to know the three. And if it's equal to k, it's the same as one above over k w squared. So you need to memorize the table of differentiable equation of order 1 and this one of order 2. Thank you for listening.